Okay, so this is a new chapter, but not only is this a new chapter, but this is actually the first chapter for a new topic. So now we're getting into probability. So chapter 4, this current chapter is Introduction to Probability. Chapter 5 and Chapter 6, they're about probability distributions. So remember we talked about discrete and continuous variables, right? We're going to continue to talk about discrete and continuous variables, but within the context of a probability distribution. And then Chapter 7 is kind of going to wrap it up, bring things together, and talk about sampling distributions. So probability is important, right? Because we need to understand it to make decisions in life and in business. But importantly, probability is also the building block for understanding inferential statistics. So we learned about inferential statistics in Chapter 1. Well, the basics of that is probability. So we're going to learn about probability, how to calculate them, but really what we're doing is we're building up, learning from chapter to chapter the concepts of probability and how ultimately they relate to sampling distributions, which is that foundation for understanding inferential statistics. So bear with me through the next few chapters. We're going to get through them together. So in this video, we're really just going to talk about terminology. There are things you already know, but you probably just haven't heard the specific terms for them. So I'm gonna read you the terms and then show you an example that's really simple, rolling the die to make sense of it. So first, probability ranges from 0 to 1. You probably already know that. Anything close to 0 means it's unlikely, and anything close to 1 means it's near certain. So hey, what's the chance of rain today? It's 50-50. What do we mean by that? 50% chance it will, 50% chance it won't. So what's 50%? 0.50. So it falls in between this 0 to 1. 0.5, right, falls in between. So it's a 50-50. It's not that it's unlikely, it's not that it's likely, it's somewhere in between. So that's the first basics of probability. A random experiment is a process that generates experimental outcomes. On any single repetition, which is also known as a trial, the outcome that occurs is determined by chance. That's a mouthful. We're going to come back to it. It'll make sense when we talk about an example. The sample space for a random experiment is a set of all of the possible outcomes. An experimental outcome is also called a sample point. The sample point is an element of the sample space. That's a lot of jargon, people. Let's talk through it. So an example that you already know all of this. What is the probability of rolling a 2, assuming that you have a fair die? Right? You already know there's 6 possible outcomes, right? You could roll a 1, 2, 3, 4, 5, or 6. So what's the probability of rolling a 2? 1 out of 6. You already know that. So let's apply the terminology that we just talked about. So I know this is a little cluttered here, but let's look in the middle here. Right here are your possible outcomes, 1, 2, 3, 4, 5, or 6. Right, those are the outcomes, right? What are experimental outcomes? We already said that. Those are sample points. So these are your possible sample points. All of your sample points put together make up your sample space. Right, so here's your sample space right here. It's made up of the different sample outcomes. The sample points, which are just the experimental outcomes. And let's say that we were interested in an event. What's an event? It's a collection of sample points. So for example, the event that someone rolls at least a 3. Well, you could roll a 3, you could roll a 4, a 5, or a 6. So this right here makes up an event. Right? An event is a collection of sample points. So here's your sample points. It's a collection of them. Why is this important? Because we might want to know, hey, what's the probability that I roll at least a 3? Right? What's that probability? Well, we have to figure out, well, what is the event? Is it probably, we're interested in, right? We want to know, what are the chances I roll at least a 3, 4, 5? So you have to be able to define an event before you can assign a probability to it. So that's the basics, the background to it. So you already know all this, so now we're just applying the terminology. So let's go back to the slide with all the definitions. So the random experiment is a process that generates experimental outcomes. Well, what is it? Just rolling the die. That is a random experiment. It's a process, right? Rolling a die that generates outcomes, right? You could roll 1, 2, 3, 4, 5, or 6, right? On any single trial, right? Rolling the die. The outcome that occurs is determined by chance, right? And isn't that true when you roll a die? If it's fair, it's determined by chance. A sample space for a random experiment is a set of all the experimental outcomes, right? We already talked about the sample space, right? For rolling the die is a set of all the outcomes, right? 1, 2, 3, 4, 5, or 6, right? That's the sample space. And we see that here, the sample space, right? All the possible outcomes. And then an experimental outcome is also called a sample point. The sample point is an element of the sample space, right? That's what we see. The sample points are the experimental outcomes from the sample space. And that's all there is to it. So being able to define and identify sample spaces, sample points, and events is important because it allows us to assign probabilities, which ultimately that's what we care about. So why is all this terminology important? Right? It's important because we have to be able to understand what they are, because once we're able to identify, hey, what's the sample space, right? What are the sample points, right? What is the event we're interested in? If we can define those, then we can start assigning probabilities to determine what we're interested in, ultimately, those probabilities.